Okay, hi. The topic today is mathematical modeling using first order differential equation. So we are going to focus on one modeling of application only, which is called Newton's law of cooling. So Newton's law of cooling can be stated as the rate at which the temperature T changes in a cooling body is proportional to the difference between the temperature of the body and the constant temperature Ts, okay, of the surrounding medium. So we can formulate it as this one, dt over dt, okay, meaning the rate of change of the temperature, okay, the body temperature respect to time is proportional, okay, proportional to the difference between the temperature minus the temperature of the surrounding, body temperature minus the temperature of the surrounding. Okay, so from here we can represent it as the first order initial value problem, this one, okay, dt over dt, okay, d capital T over d small t is equals to negative k, okay, multiplied by the difference t of the body minus the t surrounding, temperature of the surrounding. Okay, so we have the initial value condition here. T is equals to T naught, okay, when time is 0. When time is 0, okay, the temperature is can let equals to T naught. So this is fixed. So you have to know that if the temperature of the body is greater than the temperature of the surrounding, so what the situation is, we call it cooling. So the derivative will be the rate of change, okay, of the temperature respect to time will be decreasing. If the temperature of the body is less than the temperature of the surrounding, so the situation we call it heating, okay, so the rate of change of the temperature will be increasing, will be increasing. So now how to solve this Newton's law of cooling? So this type of problem, solving the differential equation. So just now, this is the first order initial value problem that we learned previously. Okay, I've explained this now. So what we can do is we know that this is actually a separate variable. Okay, separation of variables. So the variable is the temperature and the time. T, the capital T is the temperature, the small t is the time. So we have two variables here. So we want, our objective is we want to separate the temperature and time, okay, the capital T and the small t. So we will put the capital T on the right, on the left hand side, and the small t, which is only dt, on the right hand side. So we start with this one, we separate, so we get it, d capital T divided by t minus ts is equals to negative k dt. So now we will have to integrate both sides of the equation here. So we put the integration, okay, and then we can integrate. So the left hand side we will integrate respect to the capital T, the temperature, and the right hand side we will integrate respect to the small t, which is time. So this one we get ln t minus ts, and the right hand side we got equals to negative kt, and then we'll apply the properties of natural logarithms and simplifying we get this one. We put exponent both sides, so we obtain, we get here, we put exponent, we get exponent ln t minus ts is equals to exponent negative kt plus c, right? So we obtain t minus ts is equals to exponent negative kt dot exponent c. So t is equals to a exponent negative kt plus ts, okay, where a is equals to exponent c. So that's why you obtain it here. Okay, so just apply the properties of natural logarithms. So that's how you solve the solving the differential equations when it involves Newton's law of cooling. So to solve this, what do you need actually? We need the TS. So we need the TS. We need some information on the time to find the K. So all this information you will get from a real life problems. Okay, from a sentence, from a word problem. Okay, so from that we will extract information and then we will solve it using this method. The method is very simple actually. We just apply the concept of method of separation of variables or separable equation. Separable equation. So let us take a look at this example. So example 1, a pie is removed from an oven with a temperature of 350 degree Fahrenheit and placed to cool in a room with temperature 75 degree Fahrenheit. In 15 minutes, the pie has a temperature of 150 degree Fahrenheit. So determine the time required to cool the pie to a temperature of 80 degree Fahrenheit. So what you need to do for this type of question is, oh, this is cooling, right? It's a cooling because take out from the oven, so temperature will be decreasing. So we call this one is Newton's law of cooling. So first of all, let us write what is the solution of this one. Should be T is equals to Ts plus A exponent negative Kt. So we need the Ts first. So what is the temperature of the surrounding? It's the room temperature, right? Room with temperature 75 degree Fahrenheit. So we know that Ts, the temperature of the surrounding, is 75. Temperature of the body at T equals to 0. Okay, meaning we count it. A pie is removed from an oven with temperature. So this is the initial temperature. The initial temperature will be T naught. Okay, T naught is equals to 350 degree Fahrenheit. So that's a T naught. What else do we have? We have in 15 minutes, the pie has the temperature of 450 degree. So meaning the temperature when the time is 15 minutes is equals to 150. So these are the information that we have. So what is the question 1? So they ask, determine the time required to cool the pie to a temperature of 80 degree Fahrenheit. Okay, so at T, with what time the temperature is equals to 80 degree Fahrenheit? So that's the question. So what we can do is we will start from the differential equation. Okay, we continue here. Actually, we can straight away solve it using this solution. Okay, first we need to find the A. What is the A? So how to find the A? So we use the information that we have just now. Okay, so Ts is equals to 75, right? So T naught is equals to 350. So T is equals to Ts plus A exponent negative Kt. So we substitute T naught. Ts is 75 plus A exponent negative K. T is 0 because it's the initial temperature, so time is 0. So can you find what is A here? So A exponent power 0 is 1. So A is equals to 350 minus 75, which is equals to 275. So we obtain the equation now becomes T is equals to 75, right? We know the TS is fixed, plus 275 exponent negative KT. Now our problem is to find the K, the K. What is the K? So we use another information that we have. T is equals to, the time is 15, the temperature is 150. In 15 minutes, the temperature becomes 150. Okay, so we substitute 150 is equals to 75. Okay, substitute here, plus 275 exponent negative K times 15. So it is 15K. 15K. So now we solve it. So how to solve it? We solve it one by one, step by step. Okay, so what do we get here? So in the end, you will get K is equals to 0.086 0.8662. Okay, so we can stop. You can take this decimal up to 4 decimal places. Okay, at least. So now at temperature equals to 80 degree Fahrenheit, what is the time? What is how many minutes required for it to reach 80 degree Fahrenheit? So we have the general equation now become T is equals to 75 plus 275 exponent negative 0.0866 T. So we just substitute the temperature. 80 is equals to 75 plus 275 exponent negative 0.0866 T. So now you solve for the T. So it will be 80 minus 75 divided by 275 is equals to exponent negative 0.08662 T. So you put ln, and then we obtain T is equal to 46.26. So that's the answer. It takes about 46 minutes. Okay. So determine the time. So the pie will reach a temperature of 80 degree Fahrenheit after about 46 minutes. So that's it, how you solve it. Okay. So this is the clearer version, okay, of how you write it. So now example 2. The temperature of a dead body when it was found at 3 o'clock in the morning is 85 degree Fahrenheit. So the surrounding temperature at that time was 68 degree Fahrenheit. After 2 hours, the temperature of the dead body decreased, okay, to 74 degree Fahrenheit. Assume that the normal body temperature is 98.6 degree Fahrenheit. Determine the time of the murder. So it asks for the time of the murder. So when T, okay, when we still in the normal temperature, what is the time, right? So now we can assume that the initial temperature is when the body was found, okay, when the body was found. So we assume that T naught is equals to 85. And then Ts is equals to 68. So after 2 hours, okay, the temperature of the dead body decreased to 74. So we assume that this is T2, okay. So now we count the time in hours, okay. So 74 in hours. So 74. Then, so we can solve it. We have all the information. So it asks at T, the temperature equals to 98.6. What is the time? Means ask for the times of the murder. So let us start. So first, we'll use this solution. T equals to Ts, the temperature is equals to the temperature of the surrounding, plus A exponent negative KT. Okay, the capital T is the temperature, Ts, okay, is the surrounding temperature, and T, the small t, is the time. Okay, first we substitute the T naught. At T equals 0, at time 0, the initial temperature T naught is equals to 85. So we substitute the value in the solution. 68 plus A exponent negative KT. So what do we get for the A? It's 85 minus 68. So T is 0, sorry. Equals to A. So A must be equals to what? 17, right? Okay, settle for A. So now we have the new equation becomes T is equals to, Ts is 68, okay, plus 17 exponent negative KT. So this is the equation. So now our problem is the K, right? We don't want the K. We only want the capital T and the small t only in the equation. So what we need to do is we will use the next information given. So 74 is equals to 68. Okay, we substitute in the information given. When t equals to 2, negative K times 2. So what do we get here? So K must be equals to 0.5207. So now your new equation is T is equals to 68 plus 17 exponent negative 0.5207 T. Okay, so now we obtain the general solution. The temperature, okay, the formula or the equation to find a temperature is 68 plus 17 times exponent negative power negative 0.5207 T. So now it asks for the particular solution, this one. Okay, when the temperature is 98.6. So we just substitute. 98.6 is equals to 68 plus 17 exponent negative 0.5207 T, because we want to find the T. So you solve for the T. So we obtain T 1 point negative, we obtain the negative. Negative 1.1289. So meaning negative is happened before the initial temperature that we take just now at 3 o'clock. So it asks determine the time of the murder. You don't want the negative here. So how to determine? So meaning it is 1.1289 hours, right? Before 3 o'clock. Where is it? 1.1289 hours before 3 o'clock. So how to change? First, you need to change in minutes lah. How to change from minutes? How to change from minutes? Okay, it's the time is that is one negative. Okay, 1.1289 hours before 3 o'clock. First, we need to. This one is 1 hours. Okay, this one is 1 hour. This one, so we make it in 0.13. 0.13 times 60 minutes. So 0.1, you will get it equals to 7 minutes. So this one is actually 7 minutes. So 3 o'clock minus 1 will be 2 o'clock. Okay, minus 7 minutes will be 1.53 p.m. Oh, sorry, o'clock. Is the time of death. So this is a clearer version, okay, of what I've explained just now. Okay, you can see the explanation written there. Okay, now please do this question from tutorial 1. Okay, only 3 questions. So please submit it before the due date. Thank you.